Everyone, you're welcome to solve this nice exponential problem, which is 8 to the power x plus 4. This is equal to 4 to the power x plus 2 to the power x plus 2. What is the value of x? Now, let's provide a solution here. Now, we have 8 to the power x plus 4. This is equal to 4 to the power x, then plus 2 to the power x plus 2. So the first thing to do here, we can express 8 to the power x as 4 times 2 raised to the power x, then plus 4. This is equal to 4 to the power x, then plus 2 to the power x plus 2. The next step is that 4 times 2 to the power x, this is in the form of a times b raised to the power n, which we can express as a to the power n times b to the power n. Applying this exponent property, then we have here 4 to the power x times 2 to the power x, then plus 4. This is equal to 4 to the power x, then plus 2 to the power x plus 2. The next step is that 2 to the power x plus 2, this is in the form of a to the power n plus m, which we can express as a to the power n times a to the power m. Applying this exponent property, then we have here 4 to the power x times 2 to the power x, then plus 4. This is equal to 4 to the power x plus 2 to the power x times 2 to the power 2. So let's take 4 to the power x on the left hand side, so that now here we have 4 to the power x times 2 to the power x, subtract 4 to the power x. This is equal to 2 to the power x multiplied by 2 to the power 2, which is 4. And then let's take 4 on the right hand side, so that now here we have minus 4. So from what we have here, we have that 4 to the power x, and 4 to the power x here is common. We can factor out 4 to the power x, so that here we'll have into the parentheses 2 to the power x, subtract 1. Now this is equal to, here we have 2 to the power x times 4 minus 4. So this implies that 4 here is common, so we can factor out 4 here. So we have 4 into the parentheses, we'll have 2 to the power x, subtract 1. The next step is that we have here 4 to the power x into the parentheses, this is 2 to the power x, subtract 1. Now let's take 4 multiplied by 2 to the power x minus 1 on the left hand side, so that here we have minus, here we have 4 multiplied by 2 to the power x minus 1. This is equal to 0. So as you can note here, 2 to the power x minus 1, it's common here. So we can factor out 2 to the power, that is 2 to the power x minus 1 here. So we have 2 to the power x minus 1. Let's close the bracket here. And then we have 4 to the power x. We have 4 to the power x, subtract 4, close the bracket here. This is equal to 0. The next step is that 2 to the power x minus 1, this is equal to 0. So this is the first part. The second part here is 4 to the power x minus 4. This is equal to 0. From the first part here, we have that 2 to the power x, this is equal to, let's take minus 1 on the right hand side, so this is equal to 1. On the first part here, we have that 2 to the power x is equal to 1. Now we can express 1. Now, given that a to power 0, this is equal to 1. So this implies that we can express 1 as 2 to power 0. So here this means we have 2 to power x. This is equal to 2 to power 0. And since the bases are common here, that is a to power n is equal to a to power m. Since the bases are common here, then n, the exponent, that is n is equal to m. So applying this property, then 2 to power x is equal to 2 to power 0. This implies that x is equal to 0. The first value of x is equal to 0. So let's check the second part here. We have 4 to power x minus 4. This is equal to 0. So let's take minus 4 on the right hand side. We have 4 to power x. This is equal to 4. Now this 4 is raised to power 1. Now applying this exponent property, we have that since the bases are common here, then this implies that x is equal to 1. So this is x2. We have two values of x here. We have two values of x. We have x1 and we have this x2. So the next step is let's verify that x1, which is equal to 0, and x2, which is equal to 1, satisfies the equation. Now, if you recall here, we entered 8 to power x plus 4. This is equal to 4 to power x plus 2 to power x plus 2. So let's substitute to the first value of x, which is 0. So here we have 8 to power 0 plus 4. This is equal to 4 to power 0, then plus 2 to power 0 plus 2. So this implies that 8 to power 0, this is the same thing as 1. Then plus 4 here. This is equal to 4 to power 0 is the same thing as 1. So plus 2 to power 0 plus 2, this is 2 squared, which is equal to 4. So this implies that 1 plus 4, this is 5, which is equal to 5. So the left hand side is equal to the right hand side. And this implies that x1, which is equal to 0, satisfies the equation. Let's check x2, which is equal to 1. So again here, we have 8 to power x plus 4. This is equal to 4 to power x plus 2 to power x plus 2. So substituting 1, we have 8 to power 1 plus 4. This is equal to 4 to power 1 plus 2 to power 1 plus 2. This is 1 plus 2, which is 3. So 8 plus 4 here, this is 12, which is equal to 4 to power 1, this is 4, then plus 2 to power 3, which is 8. So this is 12, which is equal to 4 plus 8, this is 12. So this implies that the left hand side is equal to the right hand side. And this implies that the two values of x, 0 and 1, satisfies the equation. So kindly follow the steps, like this video, and subscribe. See you in the next video. Bye bye.